Hey everyone, today we are going to solve this functional equation. This is a functional equation from China team selection test. It was problem 2, so this is not really easy problem. Let's start. So at first we are going to put zeros. So we get f0 equals to f0 cube. So this is same as f0 times f0 minus 1 times f0 plus 1 equals to 0. So f0 equals 0 or plus minus 1. Okay, so let's put this, and we get fx times f0 equals to the f0 cube. So let's assume that f0 is not equal to 0. Then let x equal to some y, some y time divided to f0. This is possible because f0 is not 0. So we get fy equals to f0 cube, which is just constant. So if we put this, we get c equals to yc plus c squared, c cube. So c is not 0 because f0 is not 0. So we get y plus c squared equals to 1, which is contradiction because it should be true for every y, and it's not correct. So we get f0 equals to 0. Now we will prove that f1 equals to 1. Claim to f1 equals to 1. So let's put this, actually let's copy the original equation down here so that it would be easier to see. So we get, we know that f0 equals to 0, so f this is y cube equals to this is 0, so fy in cube. So let y equal to 1, and we get f1 equal to f1 cube. So f1 is 1, 0 or minus 1. Okay, so if so let's put ones, we get f1 plus 1 equals to 2f1. So if f1 equals to minus 1, we get f0 equals to minus 2, which is not true because f0 equals to 0. Okay, now if f1 is 0, then let y equal to 1, and we get this is f1, so this is 0, and f1 again, which is 0, equals to this here, fx plus this is f1 cube, which is 0, so we get fx equal to 0, which we can see that this works because 0 equals to 0 plus 0. So this is one of the solutions if f1 equals to 1. So we have one case left, which is f1 equals to 1. Okay, now we will prove that fx equals to x. And this is our last claim, fx equals to x. To prove this, we will use this. From here, we get that fx plus 1 equals to fx plus 1. And we will use this like this. Let's subtract this 2, and from here we will get something like this: plus y cube plus fy minus fx fy plus y cube is equal to y. It's easy to check. So since notice that this is injective, because we can choose x such that this could be equal to anything. So let's assume that this is equal to z and this is also z. So we get f z plus fy equals to f z plus y. So let's copy this. So so we should get that if x equals to 0 in this, we get f y cube equal to f y cube. So actually we can just actually put x 0 in this. So if we put actually z, I'm sorry, let's put z 0 here, and we get fy equal to y. Okay, so now let's replace y with fy, and we get that fz plus y equals to fz plus fy. So this is a Cauchy function. Okay, and this will be useful to finish our problem. So we will use this in the original function. So this is same as fxfy plus fy cube, and this is equal to yfx plus fy cube. We already know that these two is equal. Simply putting x equal to 0, we will get that. We actually right here, we know that. So we have fx fy equals to y times fx. So let's replace y with fy, and we get fxy equals to fx times fy. So f is multiplicative. So now let's set these two equal, and we get fx squared equal to fx squared. So there's a theorem that if f is Cauchy function and f is more than or equal to 0 for every x which is more than or equal to 0 also, then we get f is linear. Now we already know that f is Cauchy function, and if x is more than or equal to 0, which is true because x squared is more than or equal to 0, then f is more than or equal to 0 because fx is more than or equal to 0 f x squared. So we get f is linear, so fx equals to k times x plus c for every x. So we know that f0 equals to 0, so we get that c equals to 0. And also we know that f1 equals to 1, so f1 equals 1 and equals k. And we get, after putting k and c, we get that fx equals to x. Now we have to check the answers, so we get x, y plus y cube equals to yx plus y cube, which is true. So we get two answers, fx equals to x and fx equals to 0 for every x in real numbers. And that's it. Comment down below which problem you guys want to see me solve in the next video. Goodbye.